Hi everyone, welcome back to our tutorial series. In our previous tutorial we learned about operating systems, and today's tutorial we will continue that topic with learning about interrupts. This tutorial is going to be a little shorter than the previous one, and I hope by watching this tutorial you will have basic understanding of the interrupts. So what's on our agenda today? First, we will define the interrupt. We will also provide basic concept of interrupt and its importance in operating system. Next, we move to types of interrupt: hardware, software, maskable, non-maskable, and exceptions. Thirdly, we will give some examples of an interrupt. And finally, we will summarize our tutorial. So, what is an interrupt? Interrupt is a signal emitted by hardware or software when a process or an event needs immediate attention. It alerts the processor to a high priority process requiring interruption of the current working process. In other words, interrupt in an operating system is a signal, remember this word, signal, that temporarily stops the current tasks being executed by CPU, central processing unit, so the system can handle a different, urgent task. I would like to give an example to make it more understandable. For example, imagine you are reading a book, which is your main task, and the doorbell rings, which is an interrupt. You pause your reading, you stop reading, answer the door, and then go back to reading. In information technology terms, there are 4 steps in this example. There is interrupt request when doorbell rings, save state when you pause reading your main task, handle interrupt, which is attending the doorbell, and then restore the state, which is you go back to reading to your book. Why interrupt is important? Firstly, real-time responsiveness. Interrupts permit a system to reply promptly to outside events or signals, permitting real-time processing. Second, efficient resource usage. Interrupt-driven structures are more efficient than systems that depend on busy waiting or polling strategies. Instead of continuously checking for the incidence of event, interrupts permit the processor to remain idle until an event occurs, conserving processing energy and lowering energy intake. Thirdly, multitasking and concurrency. Interrupts allow multitasking with the aid of allowing a processor to address multiple tasks concurrently. Finally, improved system throughput. By coping with occasions asynchronously, it means parallelly, interrupts allow the device to overlap computation with input-output operations or other responsibilities, maximizing system throughput and universal overall performance. Types of an interrupt. There are, as you can see on the diagram, there are 2 main types of an interrupt, hardware and software, and within these types we have few more types that we'll go through together. So what is hardware interrupt? Hardware interrupt is electronic signal from external hardware device. Remember this word, external hardware device, that indicates it needs attention from the operating system. It can be the mouse, it can be a keyboard, it can be a speaker, it can be a monitor, anything to do with computer hardware. When there is a need to use mouse, that signal will go to operating system, and then it will continue, so this was hardware interrupt. Under software interrupt, a software interrupt occurs when application program terminates or requests certain services from the operating system. It can be opening a new document, it can be downloading a new application, it can be printing, which software requires attention from the operating system. Now, the other subtypes, maskable interrupt. In a processor, an internal interrupt Mask register selectively enables and disables hardware requests. That's under maskable interrupt. Under non-maskable interrupt, a hardware interrupt for which there is no source is known as a spurious interrupt. This phenomenon might also be referred as phantom or ghost interrupts. That means sudden, unexpected interrupts which can affect the main task is categorized as spurious or non-maskable interrupt. Exceptions. Software interrupts may be triggered unexpectedly by program execution errors rather than by design. These interrupts are known as exceptions or traps. As you might guess, exceptions are under software interrupts. These are also when outside of usual operating system functions, there will be other types of interrupts that might affect the main task on hand. So let's go to examples of an interrupt. We put one diagram is to just give a little understanding of the interrupt. One key example can be moving mouse or pressing a keyboard key. As I mentioned in our first slide, when there is any task, there is any interruption occurs on the operating system, the system will send the main focus on that interrupt. The processor must stop to read the mouse position or keystroke at that instant. That means the interrupt will determine which is most important and what system needs to pay attention to. Second, these interrupts are generated by hardware devices such as keyboard, mice, network cards, disks to signal that they require attention from the central processing unit. For example, pressing a key on the keyboard generates a hardware interrupt to inform the CPU that there is a new input data. Other examples. When a program needs to perform input and output operations, it may generate a software interrupt to request the operating system's assistance. That is non-maskable interrupt. When the CPU encounters an exceptional condition that cannot be handled by the current program, this can include situations such as division by zero, invalid memory access, or illegal instruction. As you can understand, this is outside of the operating system design when something irregular, something unusual happens, like division by zero, which is incorrect, or invalid memory access when you select incorrect disk, or illegal instruction. For example, illegal instruction. For example, without connecting proper cables to a screen, you try to give a task to the operating system to connect to the monitor, or you give a task to put your slides on a present mode without following the steps. This can also be an exception condition, as we mentioned earlier, as a good example for an interrupt. Well, let's conclude our tutorial. So we basically try to define the interrupt. We try to give basic concepts of an interrupt and its importance in operating system. We went through some of the types of interrupt, hardware, software, and what are the subtypes under each. We also tried to give some examples of an interrupt by giving real-life examples. And then we also included some of the diagrams to make it easier for our viewers to understand. So this was our tutorial for today. Short and sweet. I hope you gained basic understanding of the interrupts and you can easily explain the meaning, the functions, the importance, and give some of the examples from our tutorial. Continue following us, put a like button, and subscribe to our channel. Let's continue learning together. Thank you. And see you in our next session.